I'm Eugene OBrien. I'm leader of the Smart Cities and Infrastructure Cluster, the Earth Institute. I'm a bridge engineer, so I started my career designing bridges before I came into the university. So I'm interested in bridges. These days I'm working on loading and dynamics. So we're doing a lot of work on the traffic loading on bridges. So what is the probability of an incredibly large number of incredibly heavy trucks being on the bridge at the same time? Sounds like an easy question, but we've spent many years working on it and we're not finished yet. We're also looking at damage detection. So are there smarter ways of spotting that a bridge might have been damaged? Maybe a truck driving underneath bashed off it and it did some damage. And is there a way we could detect that remotely without a person having to go out and have a look underneath? Well, to some extent you might say hazard prevention. It's also how do you manage hazards? How do you deal with hazards? So you know that there's always one crazy driver that has an incredibly heavily overloaded truck. So how do you deal with that? How do you have a system of enforcing to prevent that? Can you detect that, and can you reduce the risk of that happening? Well, the first thing we need to remember is that impact is long term. It does take quite a few years sometimes for these things to come to market. But we have already made significant contributions to an understanding of the loading on bridges. This means that we will design our bridges more accurately for what exactly is on them, which means we won't have as much wasted material. And you have to remember that concrete and steel are both incredibly carbon intensive materials. So concrete is made from cement, and cement is made by crushing limestone. It's a very energy intensive industry, and it also releases carbon in the process. So we want to minimize the use of concrete and steel, and we can do that by making slightly more slender bridges and bridges that are more durable and will last longer.